So the next topic is law of radioactive decay. So Rutherford and Soddy gave the following laws for radioactive decay. So the first law is that the atoms of the radioactive substance are constantly disintegrating into new atoms by emission of alpha ray or beta ray, usually accompanied by gamma ray. Okay. So if you have some radioactive sample, that is some amount of uranium, thorium or plutonium, the atoms of that sample are constantly decaying or disintegrating to become stable, and as a result some new atoms are formed. Okay, new atoms of different elements are formed. So, and this happens by emission of alpha ray or beta ray. Okay, and this emission of alpha ray and beta rays are usually accompanied by gamma ray, as we said, because the newly formed, the daughter nuclide or the newly formed nuclei generally are in a higher excited state, higher energy state. So to come back to the ground energy state to become de-excited, they generally emit gamma radiation. So immediately after emission of alpha ray and beta ray, there may be emission of gamma ray. So the next law is that it gives us the rate of disintegration. So the rate of disintegration, which is the number of atoms disintegrating per second of a radioactive sample at any instant of time, is directly proportional to the number of atoms present in that sample at that instant. Okay. So suppose you start with some radioactive sample. Initially there are 1000 atoms. So the rate of disintegration will be highest. So with passage of time, those atoms are constantly disintegrating, decaying. So the number of undecayed atoms are gradually decreasing. As a result, the rate of disintegration also decreases. So this is also known as activity of a radioactive sample. So any radioactive sample is most radioactive initially, and with passage of time, the activity or the rate of disintegration of that sample gradually decreases. So now we will mathematically find an expression for this radioactive law. So at first, let N be the number of active nuclides. Active nuclides means those nuclides which have not suffered any kind of radioactive decay till now. Okay, present in a radioactive sample at any instant of time t. So naturally, initially at time t equals to 0, there must have been greater number of nuclides. Some of them have already suffered, they have already undergone decay or disintegration. So at any instant of time t, now there are less number of nuclei, let it be n. Okay. Now with again passage of time, this n number of nuclei are again decaying, disintegrating. So if in a small time interval of dt, if dn number of atoms suffer disintegration, undergo disintegration, then according to radioactive law of decay, what is it? It says that the rate of disintegration is proportional to the number of atoms present in that number of undecayed atoms present in that sample. Okay. So this law of radioactive decay, it will be dn dt, rate of disintegration is proportional to the number of atoms present at that moment, that is n. At any instant of time t, the number of atoms present in that sample is n. After a small interval of time, okay, dt, that is at the instant of time t plus dt, the dn number of atoms decayed, so number of atom becomes dn n minus dn. So at that instant of time, the rate of disintegration dn dt is proportional to the number of atoms present in that sample undecayed, which is n. So dn dt, so now why we are using a negative sign here? It indicates that with increasing time, the number of undecayed atoms in the sample gradually decreases. So dn dt is equals to minus lambda n. So to remove that proportionality sign, we bring one proportionality constant, which is lambda.